All right, continuing on here. Let me get a share screen going. So there are a number of built-in functions that we've already seen. The update function all the time. It's a function that's called every game cycle or every frame. This is every time something gets drawn to the screen. This is what this happens. Every update function in the game is run. There's also something called the late update, which is also called every game cycle, every frame, but it's called after the update function. So it goes through and does all the update functions, then it goes through and does all the late update functions. This is useful for ordering things. So a camera follow script might want to execute after things have been moved around. So they move around in the update, and the late update then points the camera in the right direction. There's also the fixed update function. This is the function that's called at regular time intervals, set in the time manager, 0.2 or 0.02 seconds, 50 times per second. And this is when the physics gets done. So anytime we're applying forces, we want to do that in the fixed update function, not in the update or the late update, because those occur at the frame rate, not necessarily at a uniform rate. And if we apply force, we want to do it in a uniform way. The awake, you've seen both the awake and start, and I haven't really distinguished between the two, but the difference is, first of all, the order. Awake comes before start. A before S in the alphabet is how I remember. And awake occurs when the object is instantiated or when the game starts, whereas start is only executed when the script is enabled. And scripts can be disabled to begin with. So for instance, over here on the spotlight, if I turn off this little check mark here, that script is not enabled. And so its awake function would run, but its start function would not. And we can then perhaps enable it from another script. Another script can reach in and enable that. So awake and start, and both awake and start run before any updates. So before any updates anywhere in the game run, all the awakes and all the starts have to run. And awakes occur before starts, and starts only occur on objects whose scripts are enabled. We've seen the on-trigger enter. On-trigger enter is something that works with colliders. Colliders who have been set to be is trigger send messages, and those messages are sent to both the trigger collider and to the rigid body or the collider if there's no rigid body that touches the trigger. So both the collider and the collidee get this on trigger enter message. Trigger events are only sent if one of the colliders has a rigid body though. So a simple script that would destroy everything that enters the collider that's set to be as trigger. Collider other is what collided with the trigger, and we're destroying that other game object. So that would destroy anything that came into the trigger. You could have like a shield that would destroy bullets. On trigger exit is called when the collider has stopped touching the trigger. So on trigger enter is when it comes into the collider. On trigger exit is when it goes out of the collider. And on trigger stay is called once per frame while it's inside the trigger. You might have a damage zone where if your character's in this zone, they're losing a certain number of points per second rather than being completely destroyed. They're losing points at some rate. So that's the kind of thing you can do. Now, the on-trigger events are a measure of the collision between things, but there's also the on-collision enter. And this one's a little different in that instead of having a collider as its argument, it returns a collision info object. And the collision info object has a lot of information about uh, uh, what happened in the collision. These are both described here. We have the collision class and the collider class. Collider with onTrigger, collision with onCollision. The information includes things like contact points, impact velocity, normals, all kinds of stuff. Like onTrigger exit and onTrigger stay, there's also an onCollision exit and an onCollision stay. If you're not using the collision info on a function, you can leave that the argument blank, in which case it avoids some cycles of figuring out all that information. And another thing about the onCollision events is that the colliders don't need to be is-trigger colliders. They can just be regular colliders that we're bouncing off, or that bullets are hitting, or walls that we're slamming into. Collision events are only sent if one of the colliders has a non-kinematic rigid body attached to it. Collision events are also sent to disabled mono behaviors. And so this can enable them. You can have scripting that will turn on these scripts in the case of a collision by enabling them. And collision stay events are not set for sleeping rigid bodies. You might ask, how would you have a collision stay event? Two colliders immediately push each other apart. So how do you have a stay? Well, you can have collisions between a non-is-trigger collider and an is-trigger collider, in which case they can overlap without pushing each other away. Here's an example on collision enter with collision, and we go through here for each contact point contact in the collision contact. So that's the information about the object that we've hit, all of the different contact points. We may actually be touching an object in more than one vertex. We might be touching it in several spots. And here I'm going to draw a ray from the contact point in the direction of the contact normal. So this is going to, we're hitting something. We can figure out what the perpendicular is from that surface that we've hit, and I can draw a ray from that direction. And I can do something like, say, if the relative velocity of the collision is its magnitude. Velocity is a vector, so if its magnitude is greater than 2, I can play a sound. So if it's a big collision, I can play an explosion sound. And of course, the draw ray is from a point in a direction. There's the point, there's the direction, and so it draws all these different normals. I have an example here where I instantiate a splat where an object hits at its contact point, and it's oriented with respect to the normal of the surface. So regardless of how my surface is tilted, my splat is going to lie flat on that surface. And so I have my object that I'm going to instantiate. That's the squashed circle or squashed sphere that I'm going to lay down on the ground. On collision enter, I get the collision. I go through the contact points just like I did in that last example. I form a rotation that looks in the direction of the contact normal. This is kind of similar to the look at, but it's with a quaternion instead of a vector. I draw a ray from the contact point to the normal in the color white. The draw ray, the line will persist for 10 seconds, and I instantiate my splat object at the contact point with this rotation that has the forward direction of my splat looking in the contact normal direction. And then I destroy it to clean up the scene. So let me do that one. Here's test instantiate, don't save. Test trigger, test collision, there it is. Okay, so here are my objects. My sphere and cube are rigid body objects. They both have the splat script on it with the object that they're gonna splat. You'll see that in a second. And so as these things go, oh, my splat color got lost. But you can see the normals. You can see the normals, and they're the splats being laid out. These are the normals that are displayed for 10 seconds. And you could see there that a number of them had more than one contact point where there was a collision. My splat object has lost its material. Now I'll do it again, and it'll be the right color. So we're seeing these normals to the surfaces that we're bouncing off, and every time we collide, we get this trigger message, and we get these splats going here. So all very cool. Might use that with a bullet. Another is where I have a tumbling bomb that produces an explosion that I want to be oriented with the surface that it hits. So this is basically the same thing, except now I've got some explosion thing going on here. This is the second collision here with bombs. So this was for testing. My bomb was a bunch of particle effects that sprayed out in a particular direction. So things are flowing out along the normal. And of course, using an actual bomb in this scene now. And here's that slow-mo version. So now the bombs are shooting their explosions in the directions of the normal. And this is all very cool in terms of making things work better. Debug functions, you've seen a few of them. There's debug log that logs a message to the console over here. We can also do log warnings that make a warning, they're yellow, and log errors that make an error in the console. And one of the things about an error is that you can turn on the error pause and it will stop the game at that point. This can be useful for debugging as a way to put a pause in your game so that it stops at a particular point in the gameplay. Draw array starts on a position and goes in a direction. So it's basically drawing a line from start to start plus here with a color and with a duration. If the duration is 0, it's rendered for 1 frame, but you can make it persist as long as you want. These things are only visible in the scene view unless you have gizmos on in the game view. There's also a draw line that takes a start and an end point. It works the same as draw array, except instead of a start and a direction, it's a start and an end. And so this is useful for connecting two objects. I'm going to stop there and I'll come back with the on-controller collider hit. It's kind of like on trigger and on collision. I'm going to stop recording and I'll see you in class. Bye.